this is the last section in chapter 8 about functions, operations, and compositions. When we talk about functions, when we talk about functions, we can talk about we can add them, subtract them, multiply, and divide them. That's when it talks about operations. Operations are add, subtract, multiply, divide. Those are all kind of operations. Composition is a little bit different. That's when you put a function inside a function. Placing a function inside another function. And this can kind of get sometimes tough. Usually the only ones we have problems with on the operation side is the subtracting and the dividing. Okay? And when we talk about functions, that's just f of x equals y, right? So, or y equals f of x. It means the same thing. This is just function notation. The f of x is function notation. And it reads f of x, not f times x, f of x. You're plugging x into the equation. Okay, so when you have an equation that looks like this, f of x equals, say, 2x minus 1, then when you're finding what is f of negative 1, it means you're plugging in negative 1 in for your x, and you're solving this. So f of negative 1 would equal negative 3. And now what we're going to do with these functions is we're going to perform operations of them. We're going to have, so that means there needs to be more than one operation. Okay? There doesn't necessarily have to be. You could add the same function, you know, that's fine. But usually there's two. So we're going to start with adding. And so we're going to take one function, f of x, and we're going to add another function, g of x. Okay, and that's the same thing. You can write it like that, or you can write it like this, f plus g of x. Okay, so those are the two ways that you could write that when you're adding two functions. So let's go ahead and give two functions, and then let's add them. Okay, so here are my two functions. F of x is 2x plus 3, and g of x is x squared plus 1. So we're going to add f plus g of x. So what that means, I'm taking f of x, or that was actually a g color, but that's okay. F of x, and we're going to add g of x. Okay, so here's my g of x. There. And I'm going to add, this one's not too bad. This one's just combining like terms, right? So here, I have no other x's. I have no other x squareds. So I just write this in standard form. X squared comes first, positive 2x, and then I have 3 plus 1 is 4. So there's my answer. So f of g, f plus g of x is equal to x squared plus 2x plus 4. Okay, so when we subtract two functions, this is the one that's a little bit trickier. Okay, so when I want to subtract two functions, f of x minus g of x, same thing as writing f minus g of x. Okay, so I want to use those two from the beginning. F of x is 2x plus 3, and g of x is x squared plus 1. So I'm going to take f of x, which is 2x plus 3, and then I'm going to subtract g of x. Okay, so that means I'm subtracting an x squared and I'm subtracting a positive 1. That's usually the mistake that students make, is they just subtract the x squared. But I want to subtract both of these terms here. Okay, that's the big thing. I'm subtracting both of them because I'm subtracting g of x, and g of x is this whole thing, right? not just x squared. I'm subtracting the whole thing. So that means I'm subtracting x squared and a positive 1. So then I get a negative x squared and a negative 1. Now I can just combine like terms just like I did on the adding one. And I get negative x squared now, a positive 2x, and now it's 3 minus 1, so that's a positive 2. Okay. Now you can also actually take, so this is subtracting f of x minus g of x. You can actually take g of x and subtract f of x, and that is g minus f of x. So there it just flips around, and here with adding, when you add it, those wouldn't make a difference. So when you're doing the addition one, you could do f plus g or g plus f. It wouldn't matter because 3 plus 2 is the same as 2 plus 3, right? But subtraction is different. So I'm going to take my g equation first, x squared plus 1, and then I'm going to subtract my f equation, which is 2x plus 3. So now here when I actually subtract, now I'm subtracting f, so that means I'm going to be subtracting to negative 2x. So I'm subtracting 2x, and then I'm subtracting a 3. So now when I combine like terms, the answer to f minus g of x is x squared minus 2x minus 2. Okay, so notice how the answers here are different from each other. Okay. Now when we multiply, here we have f of x and g of x. When we multiply f of x times g of x, we can rewrite that as f times, and this is a solid dot here. Okay, so it's a solid dot. So f times g of x, or we could do g of x times f of x. And again, since it's multiplication very similar to addition, here it wouldn't matter. These would be the same answer. Is the same, and this is the same as g times f of x with a solid dot there. Okay, so let's go ahead and multiply these. Like again, I said 3 times 2 is the same as 2 times 3. So it really doesn't matter. When they ask you to multiply, these two will be the same. So let's go ahead and multiply. Let's take f, 2x plus 3, and let's multiply it by x squared plus 1. So I am taking a binomial times a binomial. So that's why I probably should put parentheses here, right? Because I'm timesing both those. I'm not timesing just 3 and x squared. I'm timesing those two functions. So I'm timesing 2x plus 3 times the quantity x squared plus 1. So you can FOIL that out, or however you multiply expressions here. So another way to do it is to do an area model. So it's a 2 by 2. So I have my 2x and then a positive 3 here. So that's a 2 columns there, and then I need my 2 rows, and that's my g function. So x squared, it's a beautiful 2, and a positive 1. And then I just find the area. In area we do length times width, right? So x squared times 2x is a 2x cubed. 3 times x squared is a positive 3x squared. Then we have 2x times 1 is a 2x, and 1 times 3 is 3. Now we can combine like terms. We can't combine any like terms because this is a cube, this is a square, this is a linear. 2x is linear, and then we have our constant 3. So we just add them all together. 2x cubed plus 3x squared, starting with the largest exponent first, and then plus 2x, and then plus 3. So there's our multiplication of f times g, or g times f of x. So that's multiplication. You can do the area model, you could do FOIL here. When you have bigger ones, so if this has, say if this was x squared plus x plus 1, then you would have 3 terms, and then you would have a 3 by 2 So you have a 3 by 2 square you could multiply, or you're taking 2 by 3, which would be 6 terms. So you would have 6 terms that you would need to multiply. Okay? Okay, so here we do dividing now. So now we're going to divide them. So f divided by g of x, that's taking your f of x and dividing by g of x. Or I can have g divided by f of x. Now this is taking g of x and dividing by f of x. The big thing here that you want to do, you basically just put your whatever letters on top, you take that function, put it on top. Whatever letters on bottom, you take that function, you put that on bottom. The only thing here is you gotta state your domain. So always state your domain. And remember how we do that? We take our bottom function, right? Here we take our bottom function because it's a fraction, the only number that we can't have, right? Your domain is what can you plug in for x that you get answers out, right? So we could plug anything in for x and we'd get an answer out. The only time we don't is when our denominator would be 0. So we'd want, for this one, state our domain, we would want to set g of x equal to 0 and solve for x. And then do everything but what x cannot equal. So negative infinity up until not equal to 0. And then from there, from that number, not equal to 0, number, whatever that number is, so it might not be 0 all the time, to positive infinity. Okay? This one here, you take f of x, and you set it equal to 0, or you could say not equal to 0, it doesn't matter. And then you do the same thing. You go from negative infinity until that number that you find, and sometimes it might be a couple numbers. Okay? This is kind of like stating your domain is stating your restrictions too, what x cannot be. And it's all because we're dividing by a function and we can't divide by 0. Okay, so let's go ahead and do this one. Let's do f of g of x. So that's taking f, the function of f, put it on top, and dividing that by g, because g's on bottom. Okay, so here, one thing you want to do too is you want to now see if you can simplify, right? Just like if I have 6 over 4, I can simplify that to 3/2. Same thing here, I want to simplify. So what I do when I simplify 6/4, right? I know we can do that in our head, but what we do is we look for common factors, right? So this is 3 and 2, this is 2 and 2, so they have a common factor, right? So they cancel each other out, so I get left with 3 over 2. Same thing here. I want to look for these factors. Can I factor 2x plus 3? No, so I don't have to do anything. Can I factor x squared plus 1? No, can't do that either. So that means I can't reduce it, right? Like if I have 7/5 as a fraction, I can't reduce that because this is 7 and this is 1 and this is 1 and this is 5, right? They have no common factors but 1. Okay, so I can't cancel anything out. So on this problem, I couldn't cancel anything out. I would just state my domain, right? I would set the denominator equal to 0. Okay, and then I would solve for x. Subtract 1, x squared equals -1, square root both sides. X is equal to plus or minus square root -1, which is plus or minus I. So that doesn't matter because it's I, right? So that's an imaginary number. When we're talking about our domain, we're talking about domain of real numbers, right? Of real numbers. So this doesn't matter. So I can put any number in for x and I'll have an answer. So my domain would be from negative infinity to positive infinity. Okay, so that would be my answer right there. It's 2x plus 3 over x squared plus 1. My domain is from negative infinity to positive infinity. Now let's do another one that might reduce or might have a domain difference. Okay, so here's a problem for us. We have f of x is x squared minus 1 and g of x is x minus 1. Okay, and we're going to do, let's do f of g of x, and then we'll do g of f of x. Okay, so this one I got to take f on top, so x squared minus 1, and then divide that by g of x, which is x minus 1. So here what we want to do is we want to see if we can reduce this, right? So we're looking for factors. So can we factor x squared minus 1? Yeah, we factor that to x and x, and then 1 times 1 is 1. And then if one's positive and one's negative, they get the middle of 0, right? Because our linear term here is 0. We have our quadratic and we have our constant, but we don't have a linear. And then on the bottom, I can't factor the bottom. It's just x minus 1. So notice that these cancel out, right? So these cancel out. So then the answer to this is x plus 1, right? Of this division is x plus 1. But our domain, since we canceled these out, that means we're going to have a hole, right? So we have a hole at this factor. So again, we set our domain when we're trying to find our domain. We set our denominator equal to 0. Solve for x, so x equals 1. So we can't have our denominator 0. Even though these cancel out, what we're going to have on our graph is a hole, right? An open circle there. So we do have to state that in our domain, right? Because x cannot be 1. So in our domain, we go from negative infinity up until this 1. And it can't be that 1, right? Because we're going to have a hole there. And then from that 1, we go to positive infinity. So there would be my answer of f divided by g of x. It would be x plus 1 would be the answer. And then we state our domain. All right, now let's do g of f of x. So putting g on top, we would have x minus 1 over f of x, which is x squared minus 1. Again, we look to reduce, so this is x minus 1 over x plus 1, x minus 1. And here, oops, oh man. Okay, here, let's see if it works. Here, we factored that, right? And we didn't have to factor the top. So we can cancel these. So we get left with 1 over x plus 1. But again, since we canceled these in our domain, we still have to require that what x cannot equal in our domain, right? So here's our answer for g of f of x. Okay. But now we have to do our domain, and so we need to take our denominator and set it equal to 0. So these are two things that equal 0. We're multiplying two things that equal 0, so that means x plus 1 equals 0, or x minus 1 equals 0. So then we get x equals negative 1, and x equals positive 1. That's what x cannot be, right? Because our denominator can't be 0 here. It can't be 0 there and there. Okay, so then we go, now our domain's going to be a little bit bigger. We're going to go from negative infinity up until the lower one, negative 1, and it can't be negative 1. And then it's going to join with from negative 1 up until 1, right? We're just going from left to right, and again it can't be 1. And then we go from 1 to positive infinity. Okay, so this is saying exactly that x cannot equal negative 1 and x cannot equal 1. Even though those canceled out, we still have to state that whole, right? This one that doesn't cancel out, that's what we call vertical asymptote. Okay, now let's look at composition of functions. Okay, so composition of functions is plugging functions inside another function, right? So here are your composition of functions. You have f of g of x, of x, and that is an open circle. Remember when I was doing the multiplication, I said this is a closed circle. Now this is an open circle. So this reads f of g of x. That's how that reads, f of g of x. Okay, and what that means is I am taking g of x and I'm placing it, g of x, and I'm placing it inside of f. Okay, so this goes from the inside out, Just like f of negative 1 means that you're taking -1 and plugging it in for x. Okay, means you're plugging in -1 for x. So f of g of x means you're plugging in g of x for x. Oops. For x. Okay, that means you're plugging in a whole function, right? I'm plugging in this function into the function of f. I plug in the whole function, the whole g of x, whatever g of x equals, I plug it in for x. Okay, and this is where we get to, later we'll get to the difference quotient. Okay, it's just a really big composition of functions here. Okay, so we have that one, and then we have g of f of x, and that's taking f of x and then plugging that into g of x. Okay, that'd be plugging in f of x for x in the g function or equation. Okay, this one over here is taking g of x and plugging it in for x in the f equation or function. Okay, so here's our two functions. F of x is 2x plus 3 and g of x is x squared plus 1. And now let's go ahead and do f of g of x. So that would be taking g of x and plugging it into the f equation, right? So that's taking this whole equation and plugging it into f. So now instead of normally just being x here, I'm going to write x squared plus 1. And whenever you substitute something in, right, whenever you plug it in, you're going to put parentheses. Okay, so here's my f equation. Or maybe I should write it in blue. And now I'm going to take this x and I'm going to plug in my g. So now I have 2. And now I'm plugging in my g, which is x squared plus 1. And then I'm adding 3. Some students forget to add that 3 afterwards. Okay, so that's what it looks like. Now you start simplifying, right? So that is, I need to distribute the 2 to both of those, and then we add 3. So we get 2x squared plus 2 plus 3. So then f of g of x is equal to 2x squared plus 5. And now let's look at, some people might think, hey, are these the exact same? Is g of f of x the same thing? Well, that would be taking f of x, which is 2x plus 3, and placing that inside of g, right? So here is g, x squared plus 1. And now I'm going to take my f, which is f of x, which is 2x plus 3, and plug that in for x. So my g is my x being squared plus 1. And instead of x, it's now going to be what my f of x is, which is 2x plus 3. So that means I need to square 2x plus 3. That means I need to take 2x plus 3 and times it by 2x plus 3, and then I add 1. Don't forget to add 1 after you're done multiplying. So binomial times binomial, I should have 4 terms. So I get 4x squared, I get plus 6x, I get another plus 6x, and then I get a 9, and then I'm going to add 1, right? So we can combine like terms here. 4x squared plus 12x plus 10. So the g of f, notice it's not the same, right? These aren't the same. Sometimes they might be the same, but not always. Okay, so you can't count on it. Okay, let's look at a more complicated one, right? Because here now on f, we have multiple x's, right? So that means if I plug g into f, if I do f of g of x, that means I got to take my f, in parentheses here, I take my f, which is 2x squared plus 3x plus 1, and I got to place my g, which is x plus 1, in for these x's, right? So those x's are now going to change to x plus 1s, because that's what g is, right? Because it's f of g of x, meaning I'm taking g of x and I'm plugging it into f. So I got a place for my x as x plus 1. X plus 1. Now I got to square this first, right? Got to square this first. So I get an x squared plus 2x plus 1. And then I'm going to times that by this 2 on the outside, right? And then I could also distribute this 3. I could distribute this 3 to both of them. So I would get a 3x plus 1. All right, positive 3x plus 1. And then here I'd get a it's still blue, 2x plus 4x plus 2. And then I'm adding 1 still from over here. I'm still adding 1. Now I can combine like terms. And I forgot my x squared somewhere here. This is an x squared, right? Now I can combine like terms, so I get a 2x squared plus, that's a 4x, and a 3x is a 7x, and then 2 plus 1 is 4. So the answer to f of g of x is equal to 2x squared plus 7x plus 4. Wait, not plus 4. Where did I mess up? Right here. Look right here. I didn't distribute to both of them. Common mistake, right? I distribute to both of them. So that's 2 plus 3 plus 1. So that's not 4, that's 6. Okay. So make sure you distribute to all of them, right? Distribute to all of them. Okay, when you have parentheses and a number on the outside. All right, last thing is called the difference quotient. That's where you're going to use composition of functions, right? This is the difference quotient. It is f of a plus h minus f of a all over h. So notice that here I have a composition of functions, right? I'm taking a whole equation or a whole expression and plugging it into the equation for f, right? Here I'm plugging a in for x of my f equation. And then this one is the same equivalent, right? These are just different letters, right? A is the same as x. So here I'm taking x plus h and plugging it in for x into the f equation. Here I'm taking x and plugging it in for x. So that's really not going to change that function, right? Because I'm taking x and plugging it in for x, and then all over h. Okay, so let me give you a function. Okay, so all you need for a difference quotient is one function. It will just say, what is the difference quotient of this function, right? Or perform the difference quotient of this function, and it will give you a function. Okay, you don't need any more than that. Okay, so here I have my f equation, and I'm going to perform. I'm going to plug in a plus h in for my x, and then I'm going to plug in an a in for my x. And then it's all over h, so I can literally do that. So here's 2x plus 1, and then I'm subtracting, so I probably should put the next thing in parentheses, my f of x. Oops, I'm not going to put an x yet, because we're going to substitute that for a plus 1. Okay, and then all over h. Okay, so, oops, let me see if I can scroll down without messing it up. Okay, so my a plus h, so I'm plugging in a plus h for x, so that's a plus h here for x. And then on this one, I'm plugging in a. And now I just start simplifying this. Distribute, so 2a plus 2h, and then I'm adding my 1, right, for my function, and then here I'm subtracting. Distribute that 2, so we get 2a, and then again plus 1. This whole thing's over h. Okay, and now I can start to simplify, distribute that negative. That's a big thing. It has to go to both of them. Okay, and then we have 2a plus 2h plus 1, and then it's all over h. What's always going to happen here, what will always happen, is basically everything that doesn't have an h is going to cancel. Right, I have 2a and a negative 2a. Those are going to cancel. I have a positive 1 and a negative 1, so they're going to cancel. So I get this reduced to 2h over h, and then the h's cancel. So I get left with 2. So the difference quotient for this function is 2. And that will always happen. Everything that doesn't have an h is going to cancel, right? So if you're left with something that still has an a, then it's not just plain a, then it's not going to, then you messed up somewhere. Okay? So you could do the same thing with this if you did say f of x equals negative x squared plus, let's just do 2x plus 1. Let's make it a little more complicated. Okay, and let's do the f of x one. So we're going to perform f of x plus h minus f of x all over h, and it's the same thing as the other one. Okay, so I write my f of x, which is negative x squared, but I'm not going to write x yet because I'm going to do my parentheses. Right, because I need to plug in this first one, I need to plug in x plus h. Then it's squared. Then I'm adding 2 times my x, which again is going to be x plus h. And then I'm adding 1. And then I'm going to subtract my f of x, which is negative x squared plus 2x plus 1. Close that parenthesis, and then the whole thing's over h. Okay, so I want to plug in, for my x, I want to plug in x plus h for all my x's here, and then on this one, when I subtract my f of x, well, my f of x is the same as f of x, right? So that's just going to be x. So then here, make sure you square first before we multiply by negative, right? So I got to square that, so I get x squared plus 2xh plus h squared. Then I can multiply that negative, distribute that negative in there. Here I can distribute the 2, so 2x plus 2h plus 1. Then here, all I have to do, because all I have is x in there, all I need to do is distribute the negative, right? So it becomes negative times a negative is a positive x squared. Negative times a positive is a negative 2x, and a negative times a positive is a negative 1, and the whole thing is over h. So now we can go ahead and distribute the negative on the outside here. So negative x squared minus 2xh minus h squared plus 2x plus 2h plus 1 plus x squared minus 2x minus 1. So it's really huge, right, over h. But you notice that everything that doesn't have an h, okay, that doesn't have an h, that doesn't have an h in it, that doesn't have an h in it, that doesn't have an h, and that doesn't have an h, and that doesn't have an h. Notice, those are all opposites of each other. Negative x squared and a positive x squared, they're going to cancel. A 2x and a negative 2x, those are going to cancel. A positive 1 and a negative 1. So all that's left is something that has an h in it. Okay? And that will always happen on the difference quotients. So then what can happen, since they all have h's in it, we can go ahead and factor out that h. So we're going to pull out that h. We get left with negative 2x minus h plus 2 all over h. Now these h's, now since this is multiplication, because this is multiplication, h times this, we can go ahead and cancel these h's. Right? If that was h plus this, then we couldn't cancel those h's. Okay, so negative 2x minus h plus 2 is the difference quotient for that one. Okay, and that's pretty complicated. That would be a really complicated problem. Alright, so that's it for this whole chapter. That's done. You can go back, watch these videos. You can work on your homework. The homework is on page 266. Here are the problems. And you can get ready for your quiz and get ready for your test. That's coming up next week.